And let's look at the section 6.1, true or false problem. Number 1, the equation sine x equal to cosine x is identity. True or false? False, right? For example, you can plug in 0 for x, then left side is 0, right side is 1. 0 is not equal to 1. So this is not identity. Number 2, if we simplify the expression tangent x times cotangent x, we get what? True, right? It's true. Number 3, function f of x equal to sine square x is an even function. True or false? We know, in order to determine if a function is an even or odd function, we need to get the f of the negative x, right? Let's see. This is the sine square x. Actually, we can write this as the, right? Then sine is odd function, so you got the negative sine x inside, and this is same as the square of the sine x. So this is just the f of x. So f of x is equal to f of the negative x for all x. So this is indeed an even function. So it's true. Number 4, the function f of x equal to the cosine cubed x is an odd function. True or false? False, because cosine is an even function. Then cosine cubed is still an even function. So this is false. Number 5, if sine of 2x equal to 2 times sine x times cosine x is an identity, then so is sine of the 2x over the sine x equal to 2 times cosine x. True or false? True or false? We know this is identity, right? And let's begin with this identity, and we divide both sides by sine x, then you get this equation. So this equation is really identity, because all the values for which the both sides are well defined satisfy this equation. So this is true. Now let's look at the number 6. The equation of the sine x plus cosine x equal to sine square x plus the cosine square x is identity. False, right? And in this problem, it forgets the middle term. We have the 2 times sine x times cosine x. So it's false. Number 7, tangent is written in terms of the secant as tangent x equal to plus minus 1 minus the the square root of the 1 minus the secant square x. True or false? True or false? True. What is the right identity for the tangent and secant? You know, that should be the secant square equal to 1 plus the tangent square, right? So that means tangent square is equal to secant square minus 1. And then you take the square root of both sides, you should have the tangent x equal to plus minus the square root of the secant square minus 1, not the 1 minus the secant square. So this is false. Okay? Now let's the number 8. Very long. True or false? You see, you can couple this sine of the negative 3 with this cosecant negative 3. Together, they become 1, right? And you can couple this cosine of the negative 3 with this secant 3. So, since cosine is even function, so this same as the cosine of 3. Cosine 3 times secant 3 equal to 1. Then finally, we have only tangent of the negative 3 times the cotangent 3. And tangent is odd function, so tangent of the negative 3 is equal to negative tangent 3. So negative tangent 3 times cotangent 3 is equal to negative 1. So it's true. Right. Now number 9. True or false? True or false? What does the fundamental identity say? The sum of the sine square, right, and the cosine square is equal to 1, right? No matter what angle it is. So this guy should be equal to 1, not negative 1. So number 9 is false. Now let's look at number 10. True or false? Some guys say true. You have the a minus b times a plus b equal to a squared minus b squared, right? So this is equal to 1 squared minus the sine square of the pi over 7. Then we should have the cosine square of the pi over 7. But cosine is even function, right? And then we have the square. So this guy should be same as the cosine square of the pi over 7. So this is true. Number 10 is true.